You know, if you're a creator, an engineer, an analyst, sooner or later you're going to face the same monster. How do you take a big, ambitious technical project and actually finish it without getting totally lost? Well, today we're breaking down a blueprint for doing exactly that. Right? You get this amazing spark, this really powerful idea, but then when you actually try to start, it just feels huge. The scope keeps expanding and you just kind of freeze. So let's look at a blueprint for taming that chaos, and we're going to use a really cool real-world example to do it.
So let's start with the idea itself. Imagine a predictive maintenance system for a big data center. I mean, in an environment like that, if a critical piece of equipment fails, it can be an absolute disaster. The whole goal here is to predict when a machine, say a cooling unit, is going to fail before it actually happens.
Okay, so the concrete starting point? It's a Python script. This thing takes in raw sensor data, things like motor current, temperature, and it's designed to churn through all that noise to find the hidden patterns that signal a future breakdown. This script really is the engine of the whole project.
So what is this script actually trying to predict? It's a concept called remaining useful life, or RUL. And this is basically the holy grail of predictive maintenance. It's not just some simple red light alarm. No, it is a specific countdown, in hours or maybe days, until a machine is going to need some serious attention. That is the target our model is aiming for.
And why does this matter? Oh, the payoff here is just huge. This isn't just some techie exercise. It's about fundamentally changing how a business operates. You get to move away from that run to failure, then panic model and into a calm, proactive state. You're turning messy, noisy sensor data into crystal clear signals that let you schedule repairs and order parts way ahead of time.
Okay, so we have a great idea. It has a clear, real-world benefit. Sounds perfect, right? So what could possibly go wrong? Well, this is where we hit what I call the cognitive load trap. The project starts to feel broad, and all that momentum just grinds to a halt. Let's talk about why that happens.
And this slide, wow, this shows the problem perfectly. See, what's happening is we're mentally juggling three totally different layers all at the same time. You've got the domain theory up top, all that specific knowledge about data centers with crazy acronyms like PUE or CRAC units. Then in the middle, you have the data science, the concepts like calculating rolling stats. And at the bottom, the implementation, the actual Python code, the web servers. Trying to think about all of this at once just creates this massive mental traffic jam.
And here it is. This is the single most important piece of advice for getting out of that trap. You have to separate these layers and deal with them one at a time. You freeze the concept before you write a single line of code. You freeze the data science before you even think about building a website. If you don't do this, the project's complexity will just metastasize, growing completely out of control.
So let's diagnose this a little deeper. That feeling of being totally overwhelmed, it usually comes down to making one of three very specific, very critical mistakes. First up, we tend to get way too obsessed with capability, when what really matters is demonstration ability. We think about all the sophisticated, enterprise-grade features we could build, but the real question, especially for a portfolio project, is so much simpler. Can you explain it? Can you simulate it? Can you present the core idea cleanly? That's it. Second, our instincts are often just backwards. We almost always default to a code-first approach. We think, okay, I'll do all the heavy lifting in Python and then I'll figure out how to show it off later. But for a project that's going to end up on a static site, like on GitHub Pages, that's a recipe for disaster. The presentation shell has to come first. You have to know what the final report will look like to know what your Python script needs to create.
And the third mistake is making way too many promises. Suddenly, the project is about everything. It's about data centers and machine learning and Python and web development. There are no boundaries. The solution, though, is so powerful because it's so simple. Define the entire project with one single governing sentence.
Just look at this example. It is perfect. It's so clear. It tells you what data you're using, raw AS telemetry. It tells you the transformation, creating predictive indicators. It tells you the tool, Python. And it tells you the final output, a static site. Now, every single task you think about can be measured against this one sentence. If it doesn't serve this goal, guess what? It's out of scope. Done.
Okay, so we've diagnosed the problem, we've identified the mistakes. Now for the good part. Let's walk through the actual blueprint that takes you from that feeling of chaos to a clear step-by-step plan.
This four-phase plan is all about discipline. Phase 1, concept. You freeze the idea in a simple text document. And notice, no code,
If you can't explain it in plain English, Python is not going to save you. Phase 2, Python. Here, you use Python only as a factory to generate stuff, CSVs, charts, you name it. No fancy dashboards. Phase 3, static site. Now you build the simple HTML and CSS shell that will display what you just made. And only then, in the final optional Phase 4, do you maybe add a little JavaScript if and only if it makes the explanation better.
So let's zoom in on Phase 3, because this static site first idea is key. What you're really building is a structured story. Page 1 just sets the stage, the concept and the context. Page 2 explains your data and your assumptions. Page 3 is the main event. It's the display case for all those cool images and tables your Python script made. And Page 4 is super clever. It's where you explain what would be dynamic if this were a full-blown application. It shows you're thinking big without getting bogged down.
So here's the bottom line. For anybody out there who's feeling stuck in that overwhelmed phase, please listen to this. Your next action is not Python. Your next action is to step away from the keyboard, clarify your explanation, and lock down your scope.
And this brings us to, I think, the most important takeaway of all. Following a process like this isn't just about finishing one little project. It's about developing a much more valuable and, honestly, a much rarer set of skills.
See, by working this way, you're proving that you can think like a systems engineer, someone who can manage real complexity. You're proving you can communicate like a data analyst, focusing on clarity over everything else. You're showing that you respect constraints and can build step by step without getting lost in some fantasy architecture that was never going to get built anyway.
And that's really what it's all about, that ability to take a complex idea all the way from a concept to a clean, clear demonstration. That's what separates the talkers from the builders. It is a combination of skills that is incredibly rare, and because of that, incredibly employable.
So, I'll leave you with this question. Think about that project idea you've got on the back burner. The one that feels way too big to even start. Can you boil it all down? What is the one single governing sentence that will turn it from overwhelming chaos into focused, powerful clarity?